Now we'll discuss about the different types of electrical methods. Electrical methods, in this you have three different kinds of categories. One is the DC method or a direct current method, and the second is the electromagnetic induction method, and the third is induced polarization method. So in this video we'll explain about direct current method or DC method. So in the DC method, the physical effect that is controlling the response is based on the Ohm's law. So the excitation of the ground will be done. That means the ground will be charged with a direct current or low frequency source through the electrodes that are placed in the ground. So here there are four electrodes here, C1 and C2 and P1 and P2. The current is sent into ground through C1, C2, and the potential difference is measured by the P1 and P2. So in this method, the process of measuring the resistivity involves four electrodes. So that is why these resistivity surveys are called as four electrode methods. In this, a current is sent into the ground using the C1 and C2 current, and this pair of electrodes are called as current electrodes. Sometimes we can call them as A and B, and the potential difference is measured using the potential electrodes, and they are called as M and N or P1 and P2. Potential difference is produced as a result of the current that is flowing into the ground, and the potential difference we call it as delta V, and that delta V we are actually using to find out the apparent resistivity. So the apparent resistivity is rho A, and it is a multiplication or the product of geometric constant K and the voltage by current ratio, or you can simply make it as K into R. Here the geometric factor or the contribution factor depends on the separation or the array what you are using. We will discuss about the geometric constant and the type of separation we are using in the coming videos. So the geometric constant or the contribution factor can be calculated if we know the electrode arrangement or the electrode array. Uh, so there are a number of electrode arrays in which we can use very regular like Schlumberger and Werner mostly. We'll explain or we'll discuss about this in the later videos. Now, if we see the instrument, you have the power, like the power source you can connect to a 24 volts battery or the generator, and to measure the current and potential we need stainless steel electrodes or porous pots and the cables. See the components and also the principle of working. So the power which we are giving is a DC current or a low frequency alternating current, and the DC measurements have certain difficulties, and we need to take few precautions. The first step is we must use a non-polarizing electrode. See, when it comes to the stainless steel electrode, the metal electrodes come in contact with the ground and produce potential because of the moisture in the ground that is acting as an electrolyte. The potential from the which is coming is called as metal to solution potential, and it is to be eliminated by during a resistivity measurement. For this purpose, we are using the non-porous that are the porous pots. For this purpose, we are using a metal rod that is immersed in its own saturated solution contained in a porous pot. In general, um, porous pot with copper sulfate solution and the copper rod inserted in it. So this is a acting as a non-polarizing electrode. So the basic components involve the copper rod, terminal lid, porous pot, and copper sulfate solution. This is one thing, and that affects the DC resistivity measurements is self potential. Self potential is something that is already existing in the ground. That is because of the mineralization or potential that is created due to the presence of a fluid stream or any kind of electrolytic concentrations or geochemical actions that are taking place in the ground, and also some telluric fields. So to eliminate this kind of errors or the self potential values, we'll be either writing down the SP value here, or we the SP using the coarse and fine in this machine. So we'll get the appropriate readings. In the process, the metal or the solution potential or the self potential are usually unidirectional during the shorter time interval, and they get cancelled in the measurement. But these readings are getting average due to positive and the negative cycles here, direct and reverse. The use of alternative current will help in control SP compensation also. Right now we are discussing about the DC. So the current is measured in milliamps here, and the potential here we can see in the multi voltmeter, and we can balance the additional errors or SP values using these potentiometers. This unit has a multimeter, mill, milliammeter, or this current unit, and this is measuring the or sending the current into the ground, and this is measuring the potential difference. So we call this particular SP coarse and fine unit as a SP compensation system. The potential developed along the surfaces by simplified DC amplifier and are balanced by the potentiometers. So we can use this while going for the mineral exploration, or we can go for groundwater survey, because some people go for only SP survey, so they can check with the SP values, and then they can do the survey. And people who want to do the resistivity survey, they'll directly keep it in R mode, and then they'll take the resistance value, and by turning the quotient fine, they'll be removing the self potential value, which is an addition to the resistance value, and then they'll be taking the readings. So this is how the DC work, and the use of the stainless steel electrodes generally done in resistivity meters who are working with the alternating current.